For number 20, it says to find the range given the domain -2, -1, 0, 1, and 2. And what that means is essentially I'm just going to set up an XY chart, and they've already chosen the X values for me, the -2, the -1, the 0, the 1, and the 2. So I just have to plug these in. So I'm going to take this off to the side. 3 times 4. I'm going to plug the -2 in first. And remember, raising something to the -2nd power, it means I'm going to send this to the denominator. So that's going to be a 1 over 4 squared. And now 4 squared is a 16. And now when I multiply this, you can think of the 3 as a 3 over 1. I multiply straight across, it's a 3/16. Okay? And it's very easy to leave these as fractions because that's what negative exponents do. If I look at the next one, it's going to be very similar. I'm going to do 3 times 4 to the -1. The negative exponent sends it to the denominator, so it's 1 over 4 to the first. So now I have 3 over 1 times 1 over 4, which is 3/4. So that's my next value, is the 3/4. The following one, to the 0 power, I do 3 times 4 to the 0 power. Well, 4 to the 0 power is 1, so I have 3 times 1, which is 3. And now I have 3 times 4 to the first power. 4 to the first power is 4, so I have 3 times 4, which is 12. And then the last one, 3 times 4 to the second power. 4 to the second power is a 16, and when I multiply that by 3, it gives me a 48. And that's it. So the range here, the range is going to be the values 3/16, 3/4, 3, 12, and 48. And that's it. Okay, so when it gives me a domain and asks me for a range, it means plug those x values in, see what you get out for y. And that's it. Okay? For these next couple, it asks us to determine whether the exponential functions are growth or decay, and then to identify the a and b value. Remember, for growth or decay, we just look at the b value. And for number 22, real quickly, let's identify a and b first. A is the 0.5. It's always the number out front. It's the thing we're multiplying by. And then the b value is the thing being raised to a power. And this one is 3 raised to a power. So the b value is 3. Since the b value is greater than 1, this one's going to be growth. And that's it. For number 23, the a value, the thing out front, the thing we're multiplying by, is the 6. The b value, the thing that's being raised to the power, is 0.4. Since the b value is between 0 and 1, this one is decay. The next one, the a value, well, I don't see anything written out front. The b value is the obvious one here. It's the 4/5. Since there's nothing written out front, it means there's a 1. I'm multiplying by a 1 because that doesn't change anything. So the a value is 1. The b value is 4/5. Once again, the b value is between 0 and 1. So it's decay. And then the last one, the a value is the 2. The b value, the thing being raised to the power, is the 3/2. The b value is greater than 1, even though it's a fraction. That fraction is equal to 1.5, so the b value is greater than 1. So this one's going to be growth. And that's it. Identify A, identify B, use the B value to determine whether it's growth or decay. For this one, it says a bacteria colony has a population of 400 and doubles every 15 minutes. Modeling the equation, y equals 400 times 2 to the x, where x is the number of 15-minute periods. And we want to know how many bacteria there's going to be in 5 hours. Okay, so the first thing we're going to do is we're going to write down this equation, y equals 400 times 2 to the x, and now I just need to plug in an x value. And what they've done here is they've tried to fool us a little bit with this whole 15-minute thing. The x value is 15-minute increments, so I need to find out what the x value that I'm going to plug in is going to be if I'm talking about 500 hours. In other words, how many 15-minute increments are in 5 hours, all right? And keep this in mind, an hour is 60 minutes, so that means 5 hours would be 300 minutes. And if you want to divide that by the 15, that'll give you the number of 15-minute increments that are in this thing, which is 20. So what it's really asking me here is to plug an x value of 20 in. So just make sure your units match. Since x is the number of 15-minute increments, there are 20 15-minute increments in 5 hours, so the x value is 20. And now that's what I want to plug into my calculator. So when I do this, I have to do 2 to the 20th power first, and then multiply it by the 400. Make sure you follow order of operations. So I find out that y equals 419,430,400. Okay, so it looks like 419,430,400 bacteria. This one, it says a new motorcycle costs $12,000 to build in the year 2000. The company predicts that the cost will rise 3% per year. And we want to write the function f of t, where t is the number of years after 2000. All right, and there's two approaches you can take to this. The first of which is think of it in terms of y equals a times b to the x. If we wanted to follow that model, instead of looking at it in terms of y, I'm going to call it f of t, because that's what the question asked me to do. The a value is the initial amount. That's the 12,000. The b value, the thing I'm multiplying, the thing that's being raised to the power, since it's increasing by 3%, I have to remember that the b value is 3 plus that rate, or sorry, 1 plus that rate. So it's going to be 1.03 raised to, instead of x, I'm going to call it t because it asked me to put this in terms of years. Okay? Let me scoot these over a little bit. The other way you can look at this, there's one other model that I showed you in class, and that's this. You could think of it as y equals a times 1 plus r raised to the t. And if you think of it this way, the variables are already close to what they need to be. Instead of a y, I want an f of t. A is still the 12,000, but now I have 1 plus r. The rate as a decimal would be 0.03 raised to the t. And then the only thing I would do here is simplify this a little bit. So I get f of t equals 12,000 times 1.03 raised to the t. It's one extra step because you have to simplify, but it's a little bit easier to think of the equation that way so that you remember doing the 1 plus the rate. Okay? And then part B of this thing asks us how much money, how much will the motorcycle cost to build in 2014? Well, if I have the equation f of t equals 12,000 times 1.03 raised to the t, well, I just have to figure out what I'm going to plug in for t. Remember, this is the number of years past 2000, so t is going to be 14 this time because my initial amount started in 2000, so I'm going to plug a 14 in. So I have to do the 1.03 raised to the 14th power. After I do that to the 14th power, then I'm going to multiply by the 12,000. So it looks like in 14 years, in the year 2014, it's going to be $18,151.08. And that's it. For the next two, we just want to graph. And remember, whenever we're graphing these, we should know kind of what this thing's going to look like, whether it's growth or decay. But we also want to set up a t-chart. We want to plug in a couple values. And my recommendation is to always start with -2, -1, 0, 1, and 2. To start with those 5 values because we get some negatives, some positives, and we get 0 thrown in there, which is great. Okay, so I'm going to start with the -2. If I do 1/2 to the -2nd power, remember raising something to a negative power means we flip it. So it's 2 over 1 raised to the 2nd power. Well, it's 2 to the 2nd power is 4. And I would do the same thing with the next value. We've got 1/2 to the -1st power. I flip the fraction, and I'll raise it to the positive 1st power, which is a 2. Here I've got 1/2 raised to the 0 power. Anything to the 0 power is 1. 1/2 to the 1st power, which is 1/2. And then 1/2 to the 2nd power. I just square each piece. 1 squared. If I can write an equal sign, let me try again. 1 squared is 1. 2 squared is 4. So that's a 1/4. So now when I graph this, I just plot each of these ordered pairs. The -2, 4 is up here. The -1, 2. The 0, 1. The 1, 1/2. And the 1, 1/4. And I just do my best. And now I know what this thing's going to look like. I know it's going to be a curve. I know it's going to hug that line, the x-axis. And it's going to be decreasing. See, it decreased from left to right, which makes sense because, obviously, this was exponential decay because the b value is between 0 and 1. Okay? The last one here, once again, I want to set up a t-chart. So I'm going to set up a t-chart here, x and y. I'm always going to start with these values, the -2, -1, 0, 1, and 2. Just because they're nice values to use, I can always plug in more if I need them. And I just start plugging them in. So let's see, that's a 1/4 times 4 to the -2nd. And 4 to the -2nd power means I'm going to do 1 over 4 to the 2nd power. So that's 1/4 times 1/16, which is actually a 1/64. All right, and if you had rounded this off as a decimal, that's fine, as long as you're able to graph it. The next one, I've got 1/4 times 4 to the -1st. Again, the negative exponent flips us over the fraction bar. So now I have 1/4 to the first power, which is 1/4, and when I multiply those, it gives me a 1/16. So these aren't looking great in terms of the numbers I'm going to have to plot here. So I've got 1/4 times 4 to the 0. So it's going to be a 1/4. Hold on, my board died. All right, now it's back. 1/4 times 1, which is 1/4. So these are getting a little better. I can kind of plot 1/4. If I plug a 1 in, 1/4 times 4 to the 1st. So that's going to be 1/4 times 4, which is like 4 over 1, which equals a 1. And then I plug a 2 in. 4 to the 2nd. So that's 1/4 times 16. So that's going to be a 16 over 4, which is 4. Okay. And now what I'm going to do is I'm going to plot these and see if that gives me enough information here. So -2, 1/64. It's way down here somewhere. -1, 1/16. It's down here. 0, 1/4, maybe right there. 1, 1 is right here. 2, 4 is right here. And as I'm looking at this, I can kind of get a feel for what this thing looks like, so I think I have enough points. I know that it's exponential growth because the b value is greater than 1, so I kind of get a feel for what this thing looks like. So again, when we want to graph these, understand that you know that it's exponential growth or decay, so you should know what it should look like. And then just plug some ordered pairs in, plug some x values in, find some y values to make sure you graph this thing accurately. That's it, and good luck on your test tomorrow.